What's good, guys? Welcome back to another video. Today we're going to be talking about polynomial zeros, or in other words, finding the zeros of polynomials using rational root theorem, factoring, and also determining the possible positive, negative, and imaginary zeros using Descartes' rule of signs. So without further ado, let's get right to it. Okay, so I'm supposed to be finding all the real zeros of this one right here. The first thing I'm saying is can I factor this by grouping? If I take out 5x squared, what's going to be left behind in this case is negative 2x plus 3. And if I take that same thing out of here, let's say I take out 4 here, I'm going to get left behind 4x minus 3. So that doesn't work, right? Again, ultimately my goal here is to be able to take out the same thing for both. So that's not going to work in this case. So what I'm going to have to do is I'm going to have to use the rational root theorem. So what is that? Well, essentially what it is it is all the factors of 12, right? So what I'm thinking of is almost like my factor rainbow. Everything that multiplies to 12, plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12, all divided by the factors of 10, so plus minus 1, plus minus 2, plus minus 5, plus minus 10. And essentially what I can do is I can, any one of these possible combinations here, so any one of these fractions or whole numbers, so in this case anything over 1 would be any of the top values, or anything else is just going to be a fraction here. All of these are possible roots. So what I can essentially do is I can essentially use all of these and plug them in, see what gives me 0, and whatever gives me 0 is ultimately going to be the answer. Typically, I would always go through all of the whole numbers first and then kind of work through it that way. For the sake of time, in this case, the answer here is, I believe, just for the sake of time, the answer in this case is going to be 2. Now, how would I check that? Well, what I do is I would do synthetic division. So I put 2 here, and then I put the coefficients of each of these terms. So negative 10, 15, 16, and negative 12. And then what you do is for the first term, you just bring it down. And then what you do is you multiply the number on the outside by the term on the bottom, so negative 20. And then you add, so 15 minus plus negative 20 or 15 minus 20, negative 5, and then I repeat. So 2 times negative 5, negative 10, I add, I get 6, 2 times 6 is 12, negative 12 plus 12 ends up equaling 0. And what this does is it gives me my new value coefficients. So I know, I'm going to write this up here, that one of my binomials is x minus 2, 2 being one of my real zeros. Well, now what I do is I have my new values here. So this is going to be negative 10x squared minus 5x plus 6. And then from here, there's a number of things I can do. For example, I could just do this all over again, and then I can find my zeros. Another thing that I can try to do here in this case is I can try to factor. I'm noticing that negative 10 times 6 is negative 60. And so what I'm thinking of is what multiplies to negative 60 but adds to negative 5. Well, I know 6 and 10, but that equals 4. What else is there? There's 5 and 12. That doesn't work. There's 4 and 15. That also doesn't work. 3 and 20. That doesn't work. 2 and 30. That doesn't work. Is there anything else that I could possibly do? 11. No. It's not looking like there's anything, right? So then what does that leave me to do? Well, then in that case, what I would probably do here is use the quadratic formula. So negative b, so 5, plus or minus the square root of b squared, so 25, minus 4ac, negative 10 times 6 is negative 60, negative 60 times 4, negative 4, more like, is positive 240, all over 2a, so negative 20. Leaving me with my other zeros being 5 plus or minus the square root of 200 265 all over negative 20. And even then, actually, I'll just leave it like that. So those are all of my zeros. In this case, I got 2, and then both of these. And that would be how I'd answer this question. First thing I'm going to do, always, can I factor by grouping since I have 4 terms? In this case, I'd have to take out 2x, I guess, in this case. I could take out 2x squared, actually. Let me actually try that. If I take out 2x squared there, it's going to give me 3x minus 2. And then look at that. This one also is going to be plus 1. I'm taking out 1. That gives me 3x minus 2. Notice in this case, both of these binomials are the exact same. So what I can do here is I'm going to write this as 2x squared plus 1, and then 3x minus 2. Well, so what I'm going to do is I'm going to solve both of these separately. So in this case, this one here is going to be 2x squared plus 1 equals 0. I'm going to subtract 1 from both sides, giving me 2x squared is equal to negative 1. I divide everything by 2. And then after I take the square root, I get x is equal to plus or minus I and the square root of negative 1/2. Then for this one here, I'm going to do the same thing. 3x minus 2 equal to 0. I add 2 to this side. That's going to give me 3x is equal to 2. And then I divide everything by 3. It gives me x is equal to 2/3. Meaning all of my zeros in this case are positive 2/3 and plus or minus I times the square root negative, or not negative 1/2. In this case, I took out I square root of 1/2. Now this one's a little bit different. The reason why is because I have 5 terms. So factoring by grouping is not an option for me. So that instantly gives me to my rational roots. So in this case, plus minus 1, plus minus 2, plus minus 3, plus minus 6, all over plus minus 1. Again, because the coefficient of the first term right here is only 1. So now what I can do here is I can start just trying values. So I put my synthetic division here. Put 1, negative 1, 1, negative 3, and negative 6. And I can try any one of these combinations here. Let's just, for the sake of this, just try something. Let's say try 1, for example. Bring down a 1. 1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0. 1 plus 0 is 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. Negative 6 plus negative 2 is negative 8. So that doesn't work, right? And so essentially what I would do is I would go through all of these, trying to figure out which one best works, right? And so again, just as a recap, I bring the first number down, multiply, so 2 times 1, it gives me 2, and then I add. Negative 1 plus 2 is 1. Then I complete and redo these steps. So 2 times 1 again is 2. 1 plus 2 is 3. 2 times 3 is 6. Negative 3 plus 6 is 3. 2 times 3 is 6. Negative 6 plus 6 is 0. I found my 0. So I'm going to put x minus 2 up here. What does that give me? Well, it gives me the coefficients of my next term. So in other words, x cubed. Notice I'm going 1 degree below the highest degree term in my previous. So x cubed plus x squared plus 3x plus 3. And then from here, the first thing I'm thinking of instantly is, look, I have 4 terms. So hopefully I can factor by grouping here. And it looks like I can. If I take out the highest degree term here, I'm going to be able to take out x squared, since they both have that in common. That leaves me with x plus 1. Same thing here, I can take out a 3, so plus 3. And then I get x plus 1 again. Always, you know that you factor by grouping correctly if your terms are the same. So that gives me x squared plus 3 times x plus 1. Then I set these both equal to 0 and solve. X squared plus 3 is equal to 0. I subtract 3. I get x squared equals negative 3. And then last thing here is I take the square root. Now I'm going to get x is equal to plus or minus I root 3. So that's my 1 0, well 2 zeros actually. And then my other one is just going to be x plus 1 equals 0, and I get x equals -1. So in other words, all of my zeros, I have 2, I got -1, I got I root 3, and then I got negative I root 3, being all of my possible zeros in this situation. And what this is essentially going to do is it's going to give us our total possible amount of positive, negative, and imaginary real zeros. So the way that you do it is like this. I'm going to set up a little table of values, positive, negative, imaginary, and as well as total. My total amount of zeros possible is always going to be equal to the highest degree. In this case, this is the degree 3 zone here. In this case, it's degree 3 here. So my total possible amount of zeros here is going to be 3. And now what I'm doing is what I'm looking for is the sign changes. So in this case here, I'm looking at one sign change, right? This was positive, went to negative. 2 sign changes went negative to positive. And then 3 total sign changes, which is what I write down here. Now with Descartes' rule of signs, anytime you have a value, what I'm going to do for the positive value is I'm going to subtract 2 each time until I get to a value either at 0 or close to 0 as my possible positive values. So there's a case where I have 3 possible positive zeros, and there's also a case where I have 1 possible positive zero. Now the reason why I didn't subtract 2 again is because just like I said, it has to be either at 0 or close to 0, but it has to be positive. So ultimately, if your total value for your positive is odd, you're going to basically subtract down to 1. If it's even, you're going to subtract down to 0. Now the second thing I'm going to do is my negative values. And the way that I find my negative values is like this. I'm going to plug in negative x where each x term is, and then do the same thing where I'm looking at the sign changes. What I'm looking for in this case is actually the exponential value if it's odd or even. The reason why is because if it's odd, the sign will change. So in this case, it's going to be odd, so it's going to be negative. In this case, it's going to stay the same, so it's staying negative. The reason why is because if I plug in negative x squared is negative x times negative x, which in other words is just x, keeping the sign the exact same. So negative, negative, this is odd, so this is going to be negative, and again, this one's going to be negative here. So in other words, there is 0 negative values in this case. Well, what I do next for the imaginary values is the imaginary values is just the remainder here. So in this case, if I have 3 positive values, 0 negative values, my total is 3, then I have 0 imaginary numbers in this case. The other one is if I have 1 positive value, I'm still going to have 0 negative values, and so in that case, I have a possibility of 2 imaginary real zeros. Well, 2 imaginary zeros. And that's basically it for everything for today, guys. If you guys like this video, please like, subscribe. If you want questions done similar to this, you can always drop them in the comments. I will make all videos based on what comments are being talking about. If you want one-on-one tutoring, feel free to head on over to my website, MindLeapTutor.com. Get some one-on-one help. Other than that, see y'all next time. Take care. Peace out.